Last example problem. So the first thing we need to do is answer number 9, which is super easy to see here, which is what is recoil? Don't worry about this now. What is recoil? So recoil is a very specific conservation momentum example. And the specific example is basically where the objects start together and then split apart. So objects start together. Then split apart. But they always are going to split in opposite directions. Okay? And the reason for that is when the objects start together, they start together usually at rest, but they don't have to be. But they start with some momentum. And when one goes forward, in order to balance out the momentum, the other has to go backwards in order for that to be balanced the way it was at the beginning. Okay? So that's the idea of what's going on here for a recoil problem. Think firing a bullet out of a gun. The gun kicks back, and that's in order to do this momentum conservation. So I gave you an example here. A 900 kilogram cannon fires a 5 kilogram ball at a speed of 30 meters per second. How fast does the cannon recoil? So we're going to start off here. I'm going to do my knowns and unknowns first, but I am going to come back to a picture. But I want to list the knowns and unknowns first so you can see what's tricky about these problems. And so then you can see how the picture will help you with that. So first things first, write down what we got. So we got the mass of the cannon, and that's equal to 900 kilograms. It fires a 5 kilogram cannonball. So we're going to call that mass of CB, 5 kilograms. With a speed of 30 meters per second, how fast does the cannon recoil? So what most people would do, and what you're going to be tempted to say, is that the initial velocity of the cannonball is 30. And that makes sense, because that's what it says the cannonball's doing. But here's where you have to be careful. What's the collision? So if 30 is how fast the cannonball is going at the beginning, then what's the collision? Well, it doesn't say anything. So let's draw the picture again. So here's my cannon, here's my cannonball. Okay? Cannonball gets fired out at 30 meters per second. There we go. Okay? Is that, the 30 going out, is that actually what the cannonball's doing at the beginning? No. The cannonball getting fired out, the cannonball going out, that's not the beginning. The beginning is the cannon sitting with the cannonball in it at rest. That's the beginning. The collision is the cannonball getting fired out, which means that the initial velocity of the cannonball isn't 30. The initial velocity of the cannonball is 0. It starts at rest. Which means the 30 is the final velocity of the cannonball. Which means that the cannon's initial velocity is also 0, and its final velocity is what we're solving for. So this is where you're going to have trouble on recoil problems, is keep in mind that frequently the initial velocities will be 0. Not always, but frequently they're 0. An example would be like if you're driving on a truck that's already moving and you throw something backwards, what will happen to it? Will it actually go backwards, or will it keep going forwards? Okay. So now we're back to doing the same thing we've always been doing, which is setting up this equation and using P equals mv to find the momentum. So momentum momentum initial for the cannon is 0 because it's 900 times 0. Okay? Initial momentum for the cannonball is 0 because it's 5 times 0. Okay? Final momentum for the cannon is 900 times Vf because I don't know how fast it's going at the end. And the final momentum for the cannon, or the cannonball, is 5 times 30. So, plug them in. Initial momentum of 1 plus initial momentum of 2 equals final momentum of 1 plus final momentum of 2. I guess I didn't multiply that out. It's 150. Okay? Subtract the 150 to both sides. You get negative 150 equals 900 V final. And you get final velocity of negative 0.167. Now you might be saying to yourself, Mr. B, that number is so small. I don't know why you sound like Richard Roundtree, but that's what you sound like. Why is this number so small? First of all, notice that it's negative because in recoil, the object that's fired should cause the object that does the firing to go backwards. Okay? In order to balance out momentum, in order to do Newton's third law. And this number should be small because the mass is so large. That's why there's such a difference in the velocities, right? 30 meters per second versus negative 0.167. It's because it's a mass difference between 5 and 900. So that explains why the numbers are so different. Okay? Questions on that one? All right.